Hello everyone, welcome to Daily Leetcode Challenge. So today we have the problem of rotating a given array. So you will be given an array of n elements and you will be given a non-negative integer k. So you need to rotate the array by k steps to the right side. So the requirement here is probably we can do it using an extra space. So and the requirement, one more requirement here is, can we do it in O of an extra space? So using O of an extra space, the approach will be a little complex. So I am trying to discuss an approach where we use an additional space. So the time complexity will be O of n, and the space complexity will be O of n. So we use an additional space of for n elements. That means we use a temporary array. So let's check the examples. So when we have an array with elements 1, 2, 3, 4, 5, 6, 7 and k equal to 3, that means we need to shift the array by 3 elements to the right. So first 7 will be shifted to the beginning of the array, then 6 will be shifted before 7, then 5 will come before 6. So the new array becomes 5, 6, 7, 1, 2, 3, 4. Because k is 3, 3 elements will be shifted to right and they come to the front of the array. In example 2, we have an array with k equal to 2. So 99 and 3 becomes to the front of array. So the constraints here are the array length can be from 1 to 2 star 10 power 4, and the elements can be from max into min int, and k can be 0 to 10 power 5. So if you see here, k value can be more than the array length. That means when you are let's say you have an array of size 5 and the k value is 8, that means you need to rotate the array 8 times. So which effectively becomes you just have to rotate 3 times. So when you rotate the array by 5 times, it becomes your original array. So that then you rotate 3 more times. So that means it is effectively rotating your array 8 times. So we will see that in the example. So let's look at with an example. So this approach is basically O of n time and O of n space. We are using additional memory. So let's say our input is 5, 8, 4, 9, 11, 1, 6. The array size is 7. So these are the indexes 0, 1, 2, 3, 4, 5, 6, and we have k equal to 2. So we take a temporary array. So we try to copy every element to its actual position after the rotation. So that means we shift the element by k positions. So the element at 6th position will go to k, because k equal to 2, it will go to position 8. Then the element at index 5 goes to element index 7. Similarly, other elements will be shifted by 2 positions. Now we need to rotate the array. That means the last 2 elements which are beyond the array size, they should come to the front of the array. So now we copy it to the original array to their actual position. So how do we get 6 and 1 to their correct positions? So the index positions here are 8 and 7. So when you do a modulo with the length of your array, like size of array n, so when you do modulo n, you get your correct position. So the array size here is 7. So when you do modulo 7, so 8 modulo 7, you get 1. So 6 goes to the first index. Same way 7 modulo 7 is 0. So 1 goes to 0th index. And remaining elements will other elements will remain in the same position, because when you do modulo 7 with which index, when index is less than 7, you get the same index. So 6 modulo 7, 5 modulo 7 and so on, they will be same value. So they remain in the same position. So this is how we are going to follow in our approach. So let's look at the source code. So I have taken a temporary vector, so you can take an array as well with the same size. So as I explained you, I am not going to take n plus k here. We will take the same size. Only thing is, when we are positioning the elements, we make sure that we use modulo logic so that we get the correct position. So when you are trying to move the first element, so we add k to it. So for any given element I, so your new position will be I plus k. but I plus k can go beyond your size of array, so we do modulo with size, so that gives you the correct question. So we copy all the elements using this modulo operation, then we copy the elements back to the original array, because the array is passed with the reference, so we don't have to return it, so the elements will be updated in the original array. So let's execute and see. Yeah, it works fine. So let's submit the code and check the time complexity, execution time and memory. There seems to be some issue with the submission. Yeah, so the runtime is 8 milliseconds. So because you are doing O of n approach, memory is 10 MB because you are using some additional space. So it is a O of n and O of n time space and O of n space complexity. So probably you can, the solution has been given in Leetcode, so probably you can try to explore for doing in O of n constant space. So thanks for watching. Thank you. Please provide your feedback. Thank you.